Howdy folks, welcome back to Advent of Code 2024. We are going to be doing day 4 today. This is nice. I think this is a Christmas tree. I'm not totally sure what this is meant to be, but this is definitely a Christmas tree. This might be a spaghetti monster? I'm not totally sure. Anyway, let's look at day 4. Okay, where we go to Ceres, which is a moon of Jupiter, I want to say. I might be completely off with that. Not really much into astronomy. A small elf who lives on the station tugs your shirt. She'd like to know if you could help her find her word certs. She only has to find one word, Xmas. Words can be horizontal, vertical, diagonal, written backwards, or even overlapping other words. Still unusual, though, as you don't nearly find one instance. You need to find all of them. Here are a few ways it might appear where irrelevant characters have been replaced with a dot. Okay, so there's the diagonal. Here's that, there, that. Yeah, okay. So really any direction. The actual word starts to be full of letters. X's occurs a total of 18 times. There's the same word. Letters not involved in any X's replaced. Okay, so yeah, just all over the place. It'd be really nice. The problem I see here is they actually tell me how many times they expect Xmas to show up here, so that I can't actually check my work. That being said, I think this is not amazingly complicated. And we can code something to write this out if we need to. All right, so let's do this. So 1. So here it is. First thing we got to do, of course, get it into the system. Oops. Okay. File and sample1.txt and contents. Cool. So the way this is set up, we need to be able to move through this in any direction. If we're starting at a certain point, we need to be able to go in any other direction we need. That, to me, says we need a two-dimensional array. And two-dimensional arrays, I could do it. The thing is, you can do a two-dimensional array as a one-dimensional array and just remember and like calculate the index based on how long they are, but we're not hurting for memory. So I'm just going to go with a two-dimensional one. So, letter. I don't want to call this a map. It is technically a map, but map indicates like an object or a dictionary. I'm going to call it a grid. Okay, so then lines equals contents dot split. Okay, for lines. All right, and then these are not separated by space, and I want every letter. Letters equals line dot split. If you split on absolutely nothing, then JavaScript will split into an array of every single character. So that'll get me essentially that. Now, lines.push, letter grid. Push letters. Now let's just see what we've come up with. So that's basically just going to get our initial data. Okay. I mean, that looks... Yeah, it looks right. It's unfortunately truncating it, but that looks correct. So now I can traverse, basically with an I and J coordinate, or X and Y, I can traverse anywhere, except it's kind of backwards because the first coordinate is technically the up and down, which is the Y. So really, to index this, you'd have to use YX. It's just something you have to keep in mind. So now, the question is, how do I find every instance of Xmas here? Well, I could go along till I find an X. Okay, and then here OMAS, that's great. And then code something that looks downwards maybe, and then upwards and right, and then all the diagonals. That's pretty much what we're going to do. So what I was thinking originally when I saw this prompt, I want to use recursion, but recursion is always like, it's not always the right tool for the job, and I'm starting to think here it isn't. So the reason I thought recursion is, if once you get an X, you could just recurse in all 8 directions and be looking for the M, then the A, then the S. But the thing I'm realizing is that doesn't necessarily work because they all have to be in a straight line. So if it was recursion and these could be in any order, like X, so like if I could have something like XM and then the A is up here. Wow. something like that, like if that was a valid way of doing it, then recursion would actually be really good because you're checking all those possibilities. I don't actually need that here. I just need to go in a straight line. And because I know the length of the word is only 4, basically for every x, I know I can check this direction. So let's just do this. For line, yeah, I got to loop over it again, unfortunately. And I think, you know what? Yeah, I actually want to do that. I need the coordinates. This is going to be y equals 0. Y less than, okay, cool. And this one is actually going to be 0x line.length plus, you know, just so I'm not completely confused about what's going on. And so then our character is going to be letter grid of y x. Now, I guess I don't necessarily need to do it this way because I do have the line, but it just makes me feel better to be able to index this that way. Be interesting to actually invert this at some point just so you can index it correctly. But anyway, so we're going to carry on like this until we find not, yes, actually an x. That is completely correct. X at yx. I know we're using x for multiple things, but that's like the letter. Okay, so here's all the places there are x's. So each one of these could be an xmas, and it could be an x's in multiple directions too. And that's what we're going to find here. So the first thing we got to figure out, how do we traverse in a specific direction? And what I want to do then, let's do this. Let's make a helper function. Get string in direction. Start x, start y, off y, and count. So what this is going to do, I don't know if this is actually right. This is going to be responsible for basically, I'm going to give it a starting point, an offset x and offset y, which is like how much you add to that starting point every time, and how many to go, and it's just going to go until it finds that. So what does this do? Because this looks like it's mostly correct. Current x, current y. Okay, so every time, see, this is bad. We actually should be, because this is going to get the string. Well, no, it's not terrible. It's going to get the string in the direction not including the start x and start y, but we could actually just put that on here. Yeah. Okay, cool. And that's going to get that, that's going to get that. And then if it's, yeah, so basically it's checking if it goes off the end of the world. That 0 is completely wrong. That should be current y. Ooh. No, actually, that should be, oh, interesting. Okay, so the y is actually going to be the length of the letter grid. And the x is going to be, because the current y is our current level. They're all the same length, but this is fine. Now, see, this is why you shouldn't just trust the AI-generated code. You should always check it yourself. So that's going to return that. Okay, so get string in direction. So let's try this. So const. Let's see. Where's the first x? It says 0, 4. That's this one. Yeah, so it wouldn't be that way. So then let's see. Get string in direction. X, Y. Let's just go this way for 1, 1, 0, and 4. Process text. I just want to get the first one and quit. Okay, that is too many. Right, because I'm starting off with that letter grid. So let's do this -1. Okay, cool. So starting from that x, that's the 4 characters. So what we can do now is we can say if str equals xmas, then we need to count total xmas plus plus. We don't actually quit at that point, okay? Because we need to go on. Let's console log. Cool. Okay, so we got 3 already. That's great. Xmas, yeah, a couple. We want to go multiple directions though. So what I'm going to do, I could just duplicate this code a bunch, but I don't really want to do that. What I want to do instead is I want to set up a positions array of 1 and 0. Positions. Position. All right. And we're just going to loop over all these positions, and this is actually going to be our offset. Position 0 and position 1. No real difference, but you might wonder why the hell did I do that? Well, because now I can go the other direction as well very easily without having to duplicate a lot of code. This will be going to the left. No, we got 2 more. This will be going to up and down and 1. Oh boy, can't read parts of the length. Oh, you know why? Because this actually, we actually need to check this first. The reason we need to check that first is because the second chunk is relying on this current y to be valid. So the way loops work, or loops, conditionals work in JavaScript is this, as soon as it finds one that fails, it's going to be done for an or. Oops. So what is going to happen here is as soon as one of these is invalid, it'll fail and we'll never get here. Okay, that brings us to 8. Now we're going to do the diagonals. Let's just pop that there. So let's see. This diagonal is going to be -1, -1. Then this one is going to be 1, -1. Having some spatial sense helps here. This one is going to be positive x, positive y, 1, 1. And then this one down here is going to be -x, positive y. Okay? And we get 18. Is that correct? I don't know because they didn't tell us here. So let's just try it on our puzzle input. That is really, really big. Okay. Oh, only 140 lines. That's so few. Let's see. So let's pop this in here. 2454. Let's give that a try. Let's just see if that comes out as correct. If it doesn't, then I'll be confused. Cool. All right. So before we take a look at part 2, let's just look at our algorithm really quickly. Getting the file, pretty standard. We put our data into a nested array because it's just easier for us to traverse. The important thing about your input data is you always want to transform it into whatever structure would be easiest for you to process it in. And in that case, that is as a 2-dimensional array. So that's why we do that. We have our helper method, which is actually doing the majority of the work here. And this helper method starts from a position with some offsets. Offset's just like how much you advance that current and in what direction and how much to get. And it starts from the start and then basically loops through until we either go off the end of the world or we get our count and then it returns that 4-letter string. This lets me pivot on all 8 of those directions without a ton of nasty code. Now in here, I just go over every single letter. If I find a letter that starts the X, which is where my word is starting, then I look for this. I look in all the different directions, cardinal and orthogonal, I guess. I'm not really good on the terminology of that. Cardinal directions, I think, are these ones. Orthogonal might be these ones. That's what I'm hoping anyway. Maybe I'm wrong. Let me know. For each of those positions, it tries to get the string in that specific position's direction. And if that string is Xmas, it advances the counter. Part 2. Okay. Oh boy. There isn't actually an Xmas puzzle, it's an X method. That's so dumb. You're supposed to find 2 MAS in the shape of an X. So kind of like this. When I achieve that is like this. Irrelevant characters and achieve forward and backwards. So there's only like 4 ways this could possibly be written, right? Okay, so x mass, mass, mass. Like there's no orthogonal anymore. There's just the diagonals. And so either the m is at the top is here or here. And if the m is here, it has to be here. Here. So this we're actually focused on the a because the a is the only letter here. And in this case, this action becomes shockingly simple, I think. Um, maybe not. Oops. Let me just grab this. Okay. So instead of looking for the A, let's look for the A. Now what we're going to do then is I'm actually going to be looking now for two strings diagonal on that A, which means all of this stuff goes away. I only care about my diagonals, and not the diagonals in all directions either. I actually want, this needs to be a little bit, yeah. So this get string and direction is still fine. The thing is, I have to actually start not from my start. So if this is my current x, I need to actually shift upwards and then get the string going the opposite direction. So for here, I'd actually have to shift -1, -1, but get the string going +1, +1. Same with here. You know what? I actually need to do two lookups, I think, because I know what this looks like backwards. Probably could have fixed that in the other one too, but let's take a look here. Here we are. Okay, so positions is going to change slightly. First, I'm going to make it be a 4 number array. The first two are going to be the offset to go from. So first -1, -1. Let me just see. And then the direction to go in. And then the other one, okay, so we're going this direction. That's going to be, let's go down. So that's down y. And then the direction we're going is up. Positive x, -y. Which, funny enough, these are just actually the inverts of each other, but I don't really want to put the code for that. Okay, so equals x plus position. Yeah, start y equals, yeah, okay. And start x. So what I'm doing now is I'm just saying, okay, this needs to be, this is now my direction to go in the second two, and my start position is not actually going to be my real x. And so what I want to do, log, and then let's just check the first one that we get. Part 2. Yeah, so I start from a different, from an offset position now, here or here, and then I run in that direction. Okay. Because I can't freaking spell. Words like position are hard to spell, you know? Okay, cannot read properties behind reading 2. 16. You know what, let's do this on a sample. That's a little concerning. Oh, because that's already off the grid. Yep. So if, let's see. If, let's actually just do this entire check again here. Because now, yeah, now my start can be off the grid as well. All right. I mean, really, if the start is off the grid, we're not much hope, but start x, start y. This could be its own little function, honestly. Okay. Undefined, and this is 23. Oh. Okay. What? Still failing. You know what? Oh, that's why, because this actually needs to be a not. That whole condition needs to be false. Okay. ASM and A. That's a little weird. That's a little weird. Where am I starting from? Okay, starting from there. Huh. X, Y. Okay, let's see what we're starting with there. 7, 0. Cannot be the first time we find an A. Oh yeah, there it is, 7, 0. Okay, because it's the X, yeah. Okay. And then, first of all, we go up 1. And, oh, you know, I'm still doing 4. That's why. Let's do 3. Yeah, and that doesn't work, obviously, because that's what the diagonals look like. That diagonal is kind of weird to me, though. The AS makes sense, because that's this A and this S, but this one going the other direction should be S and A. So, it's kind of weird. Where's my start X, start Y? Okay, that is going to 6, 1, which is 1, 0, 1, 2, 3, 4, 5, 6. Yeah, so SA, so that should be SA, but it's just A. Make it just A. Huh. Oh, you know what? Because I'm actually doing that part. I'm not adding it to anything. There it is. Okay, so if stir equals mass, here's the fun part, or stir equals Sam, because they're the same thing. So I want to do another check, just like we did in part 3, 2, 3, whichever one. I'm going to do a falsity checks, or a truth sentinel here. So I'm going to say is valid equals true, and I'm going to let this prove me false. Then is valid equals false. Okay, if is valid, yeah, total live mass, Taco Bell. The total count of my X mass strings. I don't know why they all think we're stupid for this. Like, it's confusing. Okay. So you can see, yeah, actually a bunch of Sams. There's 9 now. So again, no idea if that's correct, because they don't tell, or do they tell us here? Oh yeah, 9. Okay, cool. They actually do tell us for this one. So that does work. So let's go over this before we submit. So again, same deal here. Get string and direction didn't change that much, except this additional guard went in that just says, okay, you know, yes, the start X and start Y might also be off the grid. And we should probably handle that because that wasn't possible in part 1, but now it is. The rest of this is the same. This we're still going through. We look for A. Our positions have changed now, though. So now we have the actual start position offset as well as the direction. And we just get that cross on the A. We know the A is there, so we know that we're just looking at that cross. And then we know it could be written backwards, so it doesn't matter if it's mass or Sam. I could do 4 checks, but this just seemed conceptually a little easier. Yeah, actually, 4 checks might have been harder because we wouldn't get this nice single is valid in there. You'd have to actually check if you'd gotten at least 2 valid. So you have to count the validities. Yeah, so this is a little bit better. But otherwise, other than that, the rest of this does not change. So let's run it over our input. And we get 1858, which I think is a lot fewer than we got last time. Yeah, 1858. Well, not a lot. Cool. And there we go. Day 4 completed. Thanks for watching, folks. I hope this is interesting. I'll see y'all next time.